Everyone, welcome back to Mind Over Math. This is part 3 in a series on rational functions, which are hyperbolas, talking about vertical, horizontal, and slant asymptotes. There's a part 1 and 2 that you may want to check out. In going over rational functions that are hyperbolic, let's remember that there are vertical, horizontal, and slant asymptotes. Now, we haven't talked about slant asymptotes yet. This is a good point to do that. So to do that, I'll refer to this sample right here. You may have a lot of things in the polynomial in the numerator and in the denominator, but the key is the lead term of the numerator and the denominator. Not particularly the first term, but the highest exponent term. And here we have three scenarios. One is the numerator n is smaller than the denominator m. An example of that would be over to the right here would be this one, where you have x over x squared, which will reduce to 1 over x. In this case, there is a horizontal asymptote, and that asymptote is going to be y equals 0. It is the x-axis. In the second case, the exponent on the x, on the numerator, is the same size and equal to the one on the bottom. And over here we have a sample of that. We like these because the x squareds are going to cross out, and the horizontal asymptote will be y equals 2. And then this last case is where the numerator, the n, the exponent on the x, is larger, and that illustration is down below here, where the numerator lead term has a higher exponent. In that case, you must do long division to decide, but at least we know this will have a slant asymptote with some kind of slope, or it could be even parabolic, but this will have a slant asymptote. An example of that, and that's the main one we want to deal with, would be one like this, 3x cubed plus 2 over x squared minus x minus 7. Now you can see immediately that the two lead terms have different exponents. One's larger. So the very first thing you want to do is just double check that and go over here and do a long division. And notice this will have a remainder on it. We don't care about that. What we care about is this came out to 3x plus 3 plus the remainder, whatever it's going to be. And that turns out y equals 3x plus 3 is going to be the slant asymptote. You can see that in the diagram right here down below. It goes down this way. So that's kind of interesting. So here's the graph on the next slide. You'll notice there's the original equation, and here is the red graph right here, coming down like this, and then it comes down this way through the middle, down here, and then this way. Now you'll notice I put asymptotes there. The one was the one we just calculated, and that was the slant asymptote. So you'd actually go up the y-axis to 3, and then you would go up 3 over 1, and that would make this slant asymptote right here. And you can see the graph, the red graph, doesn't cross it, it stays there. Now these other ones, I got those from the denominator right here. I put them in the quadratic formula, and I got these two equations for it, and I put them in there. You can see them. You can see them over here. So those are my vertical asymptotes. And you can see the way the graph goes there. So the solutions for limits would be varying here, and the limit as x goes to infinity in the positive direction will be infinity. It's going to go up, 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 unbounded. And then down here on the left side, the limit of x towards negative infinity, meaning we're going out to the left, following this graph, it's going to go down, 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 so the solution in the y direction is negative infinity. So this is a picture of a slant asymptote and how it changes the limit to be unbounded. Hope this helps you. This is the last part of limits with rational functions. In the upper right-hand corner, make sure you subscribe. In the upper left-hand corner, make sure you check out other videos. Likes are below and make comments on topics you need.